Okay, so the first thing we want to do is we want to sketch the graphs and figure out what the region looks like. Yeah? Yeah, let's do that. Coordinate Cartesian coordinate system, named after René Descartes, famous French philosopher. There's x squared. Here is x cubed. Okay, I didn't mean for that to quite go up so high where they intersect, but that's okay. There's our region between x squared and x cubed. Where do these two functions intersect? At the origin, that's one place, right? The origin, 0, 0. And they also intersect up here at this point, the point where x squared equals x cubed, right? Another point where x squared equals x cubed. What x value is that? X equals 1. And if we take this region and revolve it around the x-axis, we're going to get some sort of weird looking little, I don't even know what you'd call it. Like a what? A sideways bowl. Nah. You doing okay with that? You all right? When we revolve this around the x-axis, we neither get a bowl nor the opposite of a bowl. But we get, I don't know, some sort of like yeah, I mean, this looks like a banana. We get like a banana that we're like spinning around in a circle. Yeah, it's like a banana that you like spin it around in a circle. Sure, that's what a great description of it. You get a banana, like you spin it around in a circle. That's what you get. Okay. Okay. So we know that we're going to do pi times the outer radius squared minus pi times the inner radius squared, right? That's like what we do, right? Because it's going to have a gap in it. Why does it have a gap in it? Because it's not fully pushed up against the x-axis, right? There's this gap between our region and the line we're revolving around. And we're going to do pi, and we're going to do the outer radius. So which one is the outer radius? The upper function, right? Which one is the upper function? Did I draw that correctly, or did I draw that wrong? I probably drew it correctly. I did draw it correctly. Why is x squared above x cubed? That doesn't make sense. Because we're between 0 and 1, right? If you take a number that's like between 0 and like a half and you square it, it gets smaller, right? Half squared is a fourth. Well, if you cube a half, it becomes an eighth, right? That's smaller than a fourth. Okay? So if the number is between 0 and 1, when you square it, you get something smaller than what you started with, but you cube it, you get something even smaller than that. So our outer radius is x squared, so it's x squared squared. And our inner radius is x cubed. And we got to square that also. And we're going to slice this vertically in terms of x, right? And where do we integrate from? We integrate from 0 to 1. Okay? Those intersection points that we got. Good? Everybody good? You guys get it home in Zoom?
Yep.
Yes.
You guys watch the videos? Am I like really loud when I yell in there? Has anybody watched them? No? I'm glad I'm recording these and posting them on YouTube for you. Okay. 5 times the integral 0 to 1. X squared is x to the 4th. X cubed squared is x to the 6th. And what do we get? We get pi times x to the 5th over 5 minus x to the 7th over 7 from 0 to 1. And what does that become? Pi times the 5th minus the 7th minus 0. You plug in the 0. And what is that? What's the 5th minus the 7th? It'd be 7 35ths minus 5 35ths. 2 pi 7 minus 5 pi. 2 pi over 35. Units cubed. 2 pi over 35 units cubed. Good or no? You don't need to put the units cubed on the AP test. If they want units on the AP test, they will specify, indicate units of measure, and they will give you inches or miles or feet or whatever. You guys good with that at home?
Yes.
You guys good with that here? Should we do another one that you guys try and do on your own? Yeah? Okay, let's do another one that you try and do on your own. What's a good function to use? Let's take y equals, let's get the region between y equals one plus sine x and 3 plus cosine x from x equals 0 to x equals pi over 2. So we're going to revolve that around the x. Let's try and do that. That'll be fun. Does that look like fun, people at home? Good job. All right. First off, we probably tried to like sketch this a little bit. What does 1 plus sine x look like? This looks like sine, right? But up 1 unit, so it's like up here. That's not very good. It's more like this, right? And 3 plus cosine x starts up at, instead of 3, it really starts at 4, right? It's going to go this. That's not perfect, but basically they're going to look like that. Yeah, everybody agree with that? Which one is above the other one? Cosine is always above the other one. So from 0 to pi over 2, we're talking about this region right here. We are going to do the outer radius squared minus the inner radius squared. Yeah? So this should be an integral of pi times your outer radius, which is 3 plus cosine x squared, minus our inner radius, which is 1 plus sine. Everybody good with that? Okay. That is an integral that might be a little more difficult than they would expect you to solve on the AP test on your own, perhaps. So you could use a calculator to approximate it if you wanted to. But we could go through and we can do it without a calculator. Just for fun, why not, right? So this would become pi times the integral from 0 to pi over 2. We have to simplify all this out. So 3 plus cosine x would become 9 plus 6 cosine x plus cosine squared x. And then we have minus 1 plus 2 sine x plus sine squared x. That look about right to everybody? Yeah. Yeah, it might have you do this one. Okay. So then that would give us an 8, right? And we have pi times the integral from 0 to pi over 2 of 8. And what do we have? We have plus 6 cosine x and a minus 2 sine x. And then we have a cosine squared x minus sine squared x. And we talked about that one yesterday, right? What is cosine squared minus sine squared? Cosine 2x. So you're going to want to remember, why did I write 2x there? We want to make that cosine squared minus sine squared into a cosine 2x. Everybody good with that? Okay. So from there, we should be able to integrate all of that fairly easily. This should become pi. Should become 8x. And the integral of 6 cosine x is 6 sine x. The integral of -2 sine x is +2 cosine x. And then the integral of cosine of 2x, we did that one yesterday with the u sub, right? What does that come out to be? Should be
like 1/2
1/2
2x.
sine 2x. And what's the integral of cosine 3x? 1/3 sine 3x. What's the integral of cosine 7x? 1/7 sine 7x. Same thing if I wanted to take the integral of like sine 2x, that should be -1/2 cosine 2x. You just take the integral of the base function, the cosine or the sine, and then you divide by that coefficient. Right, now we just divided it. So that's 5. We got 8 times pi over 2, that's 4 pi. We got 6 times the sine of pi over 2. What's 6 times the sine of pi over 2? Sine of pi over 2 is 1. 6. Cosine of pi over 2 is 0, so that's 0. Sine of 2 times pi over 2, that's the sine of pi. What's that? 0. Then we subtract, value equals is 0, that's 0. 6 sine of 0 is 0. 2 cosine of 0 is 2. And then 1/2 sine of 0 is
0.
Wonderful. There's still someone there. I don't know. You guys are awfully quiet out there. I don't know. There's the volume on here. All right. What do we get? Pi times 4 pi minus plus 4 pi times 4 pi plus 4. 4 pi times pi plus 1. 4 pi squared plus 4 pi, or whatever you want to call it. There's your volume. Good? Everybody here good? Everybody at home good?
Yes.
Wonderful. Do we want to do another one of these, or are we okay? Another one? One more? One more. All right, I'll give you one more. Maybe a little easier one this time. Give you some confidence if you get it right. If you get it wrong, then I guess it destroys your confidence even more since it was an easier one. So hopefully you get it right. Let's do. Let's take the region between y equals 2 minus x squared and y equals 1. And revolve around x. Everybody got that? 2 minus x squared, y equals 1. Revolved around the x-axis. Ready, go. Okay, let's sketch our region. 2 minus x squared. Yeah. Y equals 1. We need to figure out where these intersect. 2 minus x squared equals 1. Well, that'd be x squared equals 1. So where do they intersect? -1 and 1. And we are talking about this region right here, which is not pushed up against the x-axis at all, right? So we're going to do pi times the outer radius squared minus the inner radius squared. Pi integral -1 to 1. Your outer radius will be your upper function, so that will be 2 minus x squared. Your inner radius will be the lower function, which is 1.
1.
Minus 1 squared. Don't really need the squared on it, but good habit to put it there. Then we'll just simplify and evaluate. Everybody at home good with that?
Yes.
Yes.
Wonderful. Great. All right. This gives us a what? 4, and then minus the 1 is going to give us a 3. And we're going to have a minus 4x squared, and we're going to have a plus x to the 4. Is that what you all got for your integral there? You integrated and got 5 times 3x minus 4/3 x cubed plus x to the 5th over 5. And then you evaluated it at 1, and you evaluated it at -1, and you found the difference. That sound all right? 1, that should be 3 minus 4/3 plus 1/5. And then at -1, that should be -3 plus 4/3 minus. And what does that come out to be? 6 minus 8/3 plus 2/5. What does that come out to be?
56 over 15.
56 pi over 15? 56 pi over 15. Sounds good to me. How do we all feel about that? Feeling okay about that? Feeling better?
Yep.
All right. Should we move on to do things that are a little different now? All right. I don't think I want to do this next problem first. No, I don't want to do that. Let's take y equals x squared, the region between y equals x squared and the y-axis. And let's say y equals 4. And let's revolve it around the y-axis. A little bit different here, huh? We're going to revolve around the y-axis instead of the x-axis. Everybody at home got that? We're going to go around the y-axis, not the x-axis.
Yes, got it.
Switching things up on you. Ooh. Scary. Do we draw a picture? Let's draw a picture. Okay. Here's y equals x squared. We don't really need the left half of it, because we're bounded by the y-axis. We're also bounded by y equals 4. We're looking at this region right there. Everybody agree that that's the region? We're going to revolve it around, and it's going to look like a bowl, except a bowl that's like totally filled in, right? That's sort of like a bowl. Okay. Everybody go with that? Yep? Yeah, okay. Wonderful. All right. Well, everything we've done so far, we've sliced it vertically. And we've opened it up and it's given us circles, or circles with a circle cut out of them. Do I get a circle if I slice it that way? Definitely not, right? Do I want to slice it that way? No. The axis that we're revolving around here is now vertical, so we will slice horizontally to get circular cross sections. Okay. When we had a horizontal axis that we were revolving around, we went, vertically, we got circles. Right? But now, the opposite. Everybody go with that? What's the thickness of each of these circles? dy.
dy.
We're going to have to do everything in terms of y instead of in terms of x. Everybody good there? So, still going to be pi. Still going to be r squared. Okay. We're going to have a dy. What's the radius? Here's that circle, right? What's the radius? It's the distance from the y-axis to the function, isn't it? In a horizontal direction. Yeah, so it is just x, right? Because that's how we measure x is the distance from the y-axis to something over here, and that's x. And so since we need it to be in terms of y, we will take our function y equals x squared and solve for x. X equals square root of 1. So that will be our radius. Everybody good with that here? Yeah. Zoom at home, are you good?
Yes.
Yep.
Great. Root y squared dy. What are our limits of integration here?
Zero and 4.
It should be 0 for the lower limit because we're going from, now in terms of y, the bottom to the top. And the top was y equals 4. So our highest value is 4. So that should be our angle. Everybody good with that? Good? So pi times the integral from 0 to 4 of y dy. Y. Oh, why not? We have pi y squared over 2 from 0 to 4, which gives us 8 pi. Because there is only one, first off, there's only one, the cross section is a circle. It's not a circle with a circle cut out of it because this region is fully pushed up against the axis we're revolving around. And so the radius of any of these circles, no matter where I draw it, the radius is from here to here. It's just x units. Does that make sense? Everybody at home good?
Yep.
Great. Wonderful. Okay, now it's even more fun. Let's take the region between y equals x squared, x equals 4, and the x-axis. And we're going to revolve around the y-axis. So it's similar to the last one we were just looking at, but it's not quite the same. What are we going to do here? Sketch a picture first? You guys sketch a picture. And then I'll draw the picture shortly after, and you'll tell me if the picture that I drew looks like the picture that you drew. It does sort of look like a bowl, doesn't it? Except that it's like weirdly rectangularly shaped on the outside. That's a pose. Okay. All right. All right. Just a little thicker than one would normally anticipate it to be. But yeah. Hopefully you got this, right? You drew your picture, you had x squared, x equals 4, x-axis. This is what we're revolving around. So we end up with something on this side that looks pretty similar, but three-dimensional, right? Yeah. Like a swimming pool or something, like a really crappy swimming pool that doesn't have a flat bottom. Like a kiddie pool. No, that seems even more dangerous. That seems horribly dangerous. Yeah, flat is good for children. Otherwise, they drown and die, and then Philip has to save them. Which I guess otherwise he wouldn't have a job. So maybe this is the pool Philip wants. I don't know. All right. Anyway, we're gonna revolve it around, and this time when we slice this, we're gonna do it which way? Horizontally or vertically? Oh, it's already on. Horizontally. And that's going to give us this time a circle with a circle cut out of the middle of it, isn't it? It's going to give us these cross sections that look like they look like rings, right? Circle. Smaller circle cut out. Y'all agree with that? At home, you guys agree with that?
Yes.
Yes.
Yep.
Wonderful. All right. Well, same concept. It should be an integral. It should be pi. It should be an outer radius squared minus inner radius squared. It should be dy. What's our upper and lower limit? What's our lower limit? 0. What's our upper limit? 16.
16.
Whoever's whispering 16 in the Zoom, you gotta yell. "16!" like that. Okay. Good job. Okay. Pi times the integral from 0 to 16. Okay. And then an outer radius. Well, what's our outer radius? It's the distance from here to here. Does that distance ever change as I move up for different y values? No. That outer radius is always how many units? 4. There's your 4 squared that you were looking for before, Philip, in the last one. That's why we did this. Just for you. All right. What about our inner radius? It changes, right, based on the value of that function, but it's always a distance from the y-axis to something over there. It's going to be x, isn't it? You guys agree that that's x? Well, what is x? X is square root of y. So we should have outer radius 4 squared minus inner radius root y squared. Good or no? Zoom, good?
Good.
Good.
Good. I feel like they're trying to go. Pi times the integral from 0 to 16 of 16 minus y dy. Just integrate. We got pi 16y minus y squared over 2, 0 to 16. Do some arithmetic here. What do we end up with? 16 times 16 ought to be 256. Okay. 16 squared is still 256. Divided by 2 is 128. We got 256 minus the 128. Got to be 128 pi, and then there's a 0. 128 pi. Good or no? Zoom good?
Yes.
Zoom good. Wonderful. All right, so 50. Right? We got lots of time still, right? We're doing good. Okay. All right, let's do another one. This one's even more fun and exciting and different. I'll let you take a second to read it, and then we'll think about what to do here. It's Tuesday. You guys realize it's Tuesday now? What? It's not Tuesday. You're wrong. It's Tuesday. All right, so I got this written down. You got a nice little picture drawn. Ready to figure out what to do? This time we're revolving around the line x equals 4. First one where we've not just done the x-axis or the y. Yeah, we're gonna have to get used to this too. We're gonna do a bunch of these. Probably finish these up tomorrow. So if I revolve around the line x equals 4, I'm gonna get something that looks like a little chocolate chip or something. Yeah, this little 3-dimensional chocolate chip shaped thing. Do you agree with that? Yeah, delicious, huh? Okay. So, slicing horizontally. Why slicing horizontally? we get circles, right? Because the axis is vertical, slice horizontally. The axis is horizontal, slice vertically. Is this going to give us rings or is it going to give us circles? Is it going to give us washers, rings, circles, right? It's going to give us circles. So we're just going to do pi times an integral of just a radius squared. And we're going to do it in terms of one, right? What's the lowest value of this region? 0. What's the highest value of this region?
3.
Right? 3, right? You get that by, we know that the highest value is at x equals 4, right? So plug in 4, you get 3. Or look at this. Or look at the graph. All right, so what's our radius? Our rings in here, I'm gonna just, that looks awful. Here's a ring. I don't like that either. I don't like that either. Having a lot of trouble. All right, here's our circular cross section. Where's the radius? It extends from here to here. That's the radius. True? Y'all agree with that? Okay, well, what is that value? X over 2? Because we're not starting at the y-axis, are we? X has to be measured from the y-axis to something. How about we do that? How about we measure that as x? Could we do that from the y-axis to whatever point we hit our function at for our radius? Everybody good with that? Zoom, good with that?
Yes.
Okay. Well, what is the whole distance from here to here? 4. That doesn't change, right? From the y-axis to x equals 4, always 4. From the y-axis to where my radius ends, always x. So what's the radius? Radius ought to be 4 minus. That's a problem, though. Why is that a problem?
Because it's in terms of x, but we are integrating in terms of y.
Right. It's in terms of x. We're integrating in terms of y. So what does x equal? Well, y over 3 equals root x over 4. Y squared over 9 equals x over 4. So x equals 4y squared over 9. So our radius is 4 minus 4y squared over 9. So that's the unpleasant looking thing that we have to put in here. And then we have to square it. And here's a good time for us to practice using your calculator to evaluate an integral, just to make sure we can do it. We could do this, right? We could distribute that out and then integrate, and the arithmetic would be unpleasant. But we could practice using your calculator to approximate. So if you don't remember how to do that, let me know. Math, option 9. $2.4? No, definitely not. Did you forget the squared? What? Did you multiply by pi? So it turned out to be 80.425. Did you guys at home get that?
Yes.
Wonderful. Did people here get that? No? Just use x. Yeah, just use x. It should. Just use x as your variable. You don't need to use y. It's just a variable, so it doesn't really matter. Anybody in here not getting that? You didn't get it? Let me know if the second time here you don't get it. You got that?
Yeah, that would 25 to 30.
Perfect. Got that? Got that? Did you forget to multiply by pi? Or forget to square it? One of the two. No. You got 80? 80, 80, 80, 80, 80, 80, 80, 80. Still not 80? 80, 80, 80. Got 80? 80. Okay. Tom, 80? What? Sure, yeah? Actually, yeah? Or just sure, yeah? It shouldn't matter for this one. People in Zoom, did you all get that? Anybody not able to get that? Having an issue? It's wonderful how responsive you all are. Great. Okay. All right, let's look at the next one. Why don't you guys try and do this one on your own? Yeah? All right, this one's just, I think, around the y-axis. Yeah, just around the y-axis. It's going around the y-axis. You're going to slice it horizontally, which means you're going to do it in terms of around the y-axis in terms of what? Yeah. Yeah. Don't worry, it's going to get even more complicated when I show you the last method to find volume using integration. And it's the opposite of this way, where when you do it around something that's horizontal, you're going to do it in terms of y. When it's around something vertical, you'll do it in terms of x. It's going to be great. You're going to love it. It's going to be fun. What? Was I with my full body? Oh. Oh.
Mr. Bachelor,
Yeah.
for the last one, how do you change the variable to y? I had it like integral of 3, 0 on top and bottom, 4 minus 4x squared.
No, it shouldn't be 4 minus 4x squared. It should be 4 minus 4y squared.
But how do you put y into the calculator?
You don't. You just type it into the next. Yeah, you don't have to. You can just type it in as 4 minus 4x squared over 9 squared, and then dx, and then you'll get the same answer.
I got 2.4 somehow.
Hold on. How'd you get 2.4 last time? What'd you do wrong?
Oh, I just added a random parentheses.
You got some parentheses in the wrong place because somebody here got 2.4 also,
And then I forgot to
and forgot to multiply by pi, perhaps.
Oh yeah. Okay. Thank you.
If you still don't get the 80.425, let me know. We'll fix your problem.
Okay.
You can also, if you're still not getting it, you can take a picture of your calculator and send it to me on Remind, and I can tell you what's wrong. All right, let's pause this. So we're at a region between the x-axis. I like it getting high. Between the x-axis, natural log of x, right? That's natural log of x. Yeah. The x-axis, and x equals e. There's ln x. There's x equals e. So we're looking at this region right here. We're going to revolve that around the y-axis. So we're going to get this like sort of bevel-looking washer sort of thing, maybe. I don't know. We're going to have this same sort of thing over here. Right? Then revolve around, and it's three-dimensional. It's just circled around, right? Yeah. Everybody good with that? Good with that? Zoom at home, zoom home, zoom home.
Yes.
Yeah. Okay. Now, two questions. One, well, more than two questions. First question. We're just going to see how many we have. First question. Which way do we need to slice it? Horizontally. Okay. Horizontally sliced. Okay, great. Second question. What does that mean about the variables? Which variables? We're doing it in terms of y, so it's going to be pi. Then it's going to be dy at the end, and it's going to be third question. Yeah, question. Yeah. Third question. Is this a disk or is this a washer? A washer, right? Because the region we're revolving around is not fully pushed up against the axis. Okay. Fourth question. What is the outer radius? The distance from the y-axis that we're revolving around to the furthest right point of this. Well, what's that? It's e. Does that ever change? No. All the way up from the lowest point of the region to the highest point of the region, the outer radius is e. E squared. Right? Because it's outer radius squared. Minus inner radius squared. What's the inner radius? Question 5. What's the inner radius? All right. Close. I mean, yeah. This is x. Actually, that's no. Close, but no. This distance from my y-axis to my function is x. And isn't that the radius? This is x, isn't it? That's our inner radius. Do y'all agree with that? Can I just put in minus x squared? Put it in terms of y. How do I do that? I go up here. E to the y equals x. Right? We exponentiate. So we know that x is e to the y. So our inner radius is e to the y. And if I square e to the y squared is just e to the 2. Y. Okay. We're doing it in terms of y. What's the lowest value of our region? 0. What's the largest value of our region? We're going up to, at e, we're going up to natural log of e, which is exactly. Everybody good with that? All right. We can integrate that. We should be able to integrate that. E squared is a constant. So when you integrate a constant, you just get that constant times the variable. So e squared times 1. And then minus, what's the integral of e to the 2y? No. That's the power rule. You can't use the power rule on that. It's a use substitution.
1/2 e to the 2y.
Yeah, so it becomes 1/2 e to the 2y. What did you say? Sorry, I missed the second half of what you said. Right, because the variable's in the power, not in the. So if you do the u sub on that, I'm just going to write it out real quick. So e to the 2y becomes e to the u, with u equal to 2y. du is 2. So when you put in the 2, you got to put in the 1/2 outside. And that's where that 1/2 comes from. It becomes 1/2 the integral of e to the u, which is 1/2 e to the u, which is 1/2 e to the 2. Everybody good there or no? Zoom good?
For the
Yes.
integral, why wasn't it e minus e to the y and then all of that squared?
Because it's outer radius squared minus inner radius squared, right? Because we're looking at rings, you're gonna find the area of the outer circle and then subtract the area of the inner circle. It's pi times the outer radius squared minus pi times the inner radius squared. If you do outer radius minus inner radius and then square, that's very different. That is not okay.
Okay, thank you.
All right, now we evaluate at 1. We evaluate at 0. We get an answer. 5 at 1, that's e squared. And at 1, that's 1/2 e squared. At 0, that's 0. And at 0, that is minus 1. Wonderful. So now we just combine e squared minus 1/2 e squared is a 1/2 e squared. We got pi times 1/2 e squared plus 1/2. I don't know, there was some e's in there. Not the e's you wanted there to be, I guess. Yeah. How do we feel about that? Good? No? Bad? Indifferent? Happy? Sad? Something? No emotion? Good but bad in arithmetic. That's a bad thing to be bad at. No. Anybody in the Zoom got a question? We're going to stop there because we're almost done with time here. So tomorrow we're going to finish up. We're going to revolve around. We did that one with like x equals 4. We're going to do a bunch more with like y equals 2 that we're going to revolve around, or y equals -7, or x equals -3, or those kinds of things. Then we'll talk about the last technique for finding volume that is not required for the AP test, but is sometimes helpful. And then we'll be moving on to only free response question practice for the rest of this year, pretty much, and going over multiple choice. That's our plan. Zoom.